This video is on adding and subtracting fractions. As you know from our practice in class, the first thing you have to do to be able to add or subtract fractions is find a common denominator. Basically, we need to divide the pieces into the same sized pieces, so that way we can combine them together. It's hard to combine big pieces with little pieces. They don't quite fit the same, so we can't just total them up and see how many we have. We have to divide everything into the same size pieces. So our first step here, step one, is we need to find a common denominator. So one fraction's been broken into 15ths, one's been broken into fifths. We want to find something that works for both of those. So our idea was take your two denominators, list out the multiples of each one of them until you find something they have in common. Basically, you're going to break them up into more pieces or smaller pieces. So you need to find something that will work. So I'm list out my multiples of 5. 5, 10, 15, 20, 25, 30. I do the same thing for my 15. And hopefully you notice right away that the first number that they have in common, the first multiple, we call it the least common multiple, is 15. That means 15 is something that I can make using 5s and I can make using 15s. That's what I want to use as my new denominator. So I want to rewrite each of my problems using my new denominator. For my first fraction here, 8/15, it already is broken up out of 8 pieces, or out of 15 pieces, excuse me, so it's going to stay 8/15. For my 1/5, I need to change that denominator, so it's going to go from a 5 to a 15. So I ask myself, what did I do to that 5 to make it into the 15? Well, I multiply it times 3. So, as we see in number 3, it says don't forget to change the numerators too. Remember, whatever you do to your denominator, you have to do the same thing to your numerator. That's how we keep them equivalent fractions. Fractions that are still equal to the same amount. So, since I multiplied 5 times 3, I do the same thing to my 1 and get 3/15. 3/15 of something is the same amount as 1/5. Yes, 3/15 is more pieces, but they're smaller pieces. Those 3 pieces combined together is equal to 1 of those fifths. So we're still talking about the same amount. Now this one was a subtraction problem, so I'm going to go ahead and subtract. 8/15 minus 3/15 is 5/15. So that's my step 4. And then my last one is always look, can I simplify? So I ask myself, is there anything that both 5 and 15 can both be divided by? In this case, they can both be divided by 5. So as long as I treat them both equally, just like when I wrote the fraction with the new denominator, I treated the numerator the same way. As long as I treat them equally, I'm still talking about the same amount of material, so I haven't changed the actual number. I'm just renaming it into larger size pieces. So 5/15 is always also the same thing as 1/3. So let's try another one. 8/15 minus 1/6. So again, my first step was I need to find a common denominator. So I list out some multiples for each one of my numbers. For some people, you might just kind of naturally know what number might work. For other people, listing out our multiples is our best option. It helps us make sure we see all of our possibilities. But hopefully you noticed that in both of my lists, I had an answer of 30, meaning 30 is something that I can turn a 6 into and a 15 into. So I'm going to rewrite each of my fractions out of 30. Now I need to rewrite the numerators to go with it. Remember, the numerator has to change the same as the denominator in order for still be the same fraction, still equal to the same amount. To get from 15 to 30, I multiply times 2, so I do the same thing to my numerator. And I get 16/30. To get from 6 to 30, I multiply times 5, so I do the same thing to my numerator and get 5/30. And now I'm ready to go ahead and subtract. 16/30 minus 5/30 is 11/30. Then I check, can I simplify it? In this case, 11 and 30 don't have anything in common. There's nothing they can both be divided by. So 11/30 is my final answer. So let's take a look at another one. 3/4 plus 1/7. Again, I need to find a common denominator. So I start by listing out my multiples for each number. I list them out for my 7. And then I compare my two lists. Hopefully you notice that the smallest number that showed up in both lists was 28. 4 and 7 really don't have anything in common, so it ended up being that the least common multiple, my new denominator, was actually just 4 times 7. And that's going to happen sometimes when the denominators don't have much in common with each other. Now I need to rewrite my numerators. So I ask, what did I do to 4 to get 28? Well, I multiplied times 7. So I do the same thing up top. 3 times 7 is 21. For my 7 to get to 28, I multiplied times 4. So I do the same thing up top and get 4 28ths. And this problem is an addition problem. So I go ahead and I add 21 eighths plus 4 eighths is 25 28ths. Then I check, can 25 28ths be simplified? In this case, it can't. There's nothing that 25 can be divided by that 28 can also be divided by. So 25 28ths is my final answer. So let's take a look at one more. This would be a good point for you to pause, try the problem for yourself, then hit play and come back and see how you did. So I'll give you just a second to get started. All right, so first thing I need to do is find a common denominator. So I'm looking at 12s and 10s. So I'm going to list out some multiples for each of my numbers. Again, if you have trouble with your multiples, use your multiplication table. It does a good job of just counting up by each of your numbers. But hopefully you notice that 60 is a good common denominator. It works for both 10s and 12s. So I'm going to rewrite each fraction out of 60. I ask myself, what did I do to 12 to get to 60? Well, I multiplied times 5. So I do the same thing to my numerator, and I get 25 60ths. To get from 10 to 60, I multiplied times 6. So I'm going to do the same thing to my numerator. 3 times 6 is 18. So now I've rewritten each of the fractions with their new denominator. I've done the same thing to my numerator that I did to my denominator. So I've kept it in equivalent fraction, something that's equal to the same amount it started with. And now I'm ready to subtract. 25 18ths minus 60 18ths, 18 60ths is an answer of 7 60ths. Then I always check, can I simplify? In this case, 7 and 60 don't have anything in common. So 7 60ths is my final answer. And that's how we add and subtract fractions. We find our common denominator, rewrite the fractions with that new denominator, write our numerators so that they change the same way our denominator is. In this case, my 12 was multiplied by 5 to get 60, so I did the same thing to my numerator. Then we go ahead and add or subtract, and lastly we finish out by simplifying our answer if possible.